Well, good morning, everybody. Yesterday we talked a little bit about some rules for naming and writing the formulas for ionic compounds. Today we're going to do a little bit more practice with that. And before I get started on showing you some specific examples, I want to talk just for a minute about if you're doing it electronically, if you're not going to print out the paper and then just do it on your own paper and hold on to it that way. What I've got here is I've got a Google slide. Let me actually make a copy of that. What you're going to need to do if you haven't already done so is you're going to need to click File, click Make a Copy, and then it'll put it into your Google Drive so that you can actually edit it. If I end up taking a grade, then you can just attach the copy to the file that you made. But a few things about getting around this. First of all, that's way too tiny the way that it's laid out for you to be able to see stuff. So what you're going to want to do is you can click the little magnifying glass button here, and you can set it for something that's a little bit bigger. That's 100%. That's, wow, that's big. That's 200%. Let me zoom back out to 100. Let's see. Once you've got it zoomed out, what I've got set up here, and you can just kind of click on the blank, I've got some text boxes set up on each one of these blanks. So that'll let you type your answer in. If for some reason you accidentally do something like moving the text box or deleting a text box, then you can just make a new one with this little text box tool here. You just kind of grab it and drag it and put a text box where you want to put one. Okay, I'm going to delete that because I really don't want one there. I'm going to actually hit Control Z to undo that. So, for starters, up where it says name, you can kind of click, and I've got a hidden text box there. And then when you go to put in your answers, you just click the text box and you type. Now, we looked at a couple of these yesterday. So I think NaBr was sodium bromide. You just type it right there in the box. If you're writing formulas like we did on the second page here, there's a couple of tips for how you can get your text to do the little subscript thing. So let me see, I think we did lithium acetate, so that's a good one. And the formula for lithium acetate was Li for the lithium, and then the acetate was C2H3O2. So here's what I'm going to do. I could just go C2H3O2, and I wouldn't be too picky about that, but to get it in correct format, all these numbers here need to be in a subscript. So the way you can do that, and you can either do it before or after you type, you can just highlight what you want to subscript. Like I'm going to highlight that first two. I'm going to come up where it says Format, Text, and I'm going to click Subscript. And you see the subscript also has a hotkey of Control comma. Now see what it did? It made that too tiny. I'm going to do the same thing with my 3, but this time I'm just going to hit Control comma on my keyboard and see it does the same thing. Does the same thing again. So that's how you can get it in the right format. You can also do it while you're typing. I think we had, what was another one we did yesterday? I think we did iron 2-phosphate. So I'm going to start typing that one, Fe. Now iron 2-phosphate was Fe3PO42. So I'm going to hit Control comma and type my 3. Now if I keep typing, it's all still going to be in that lowercase, in that subscript. So what I want to do is I want to hit Control comma again. That'll get it back to normal size. That way I can put in my parentheses for the PO, Control comma 4, Control comma, parentheses, Control comma 2. And that seems like an awful lot of steps to go through, but if you are picky about getting it right, that's how you can do it. And again, you can either do that by doing it as you type it in, or you can do it by highlighting it after you have it typed and just either hitting Control comma we're clicking Format, Text, and then the drop down will say Subscript. So I'm going to set that aside, and I'm going to be boring and work on paper because paper is a little bit faster, and I can also kind of do some scratch work out to the side here. So what I wanted to do today was basically just to practice some of the rules and methods that I showed you yesterday. So I'm going to throw it open to you in the chat, and on this first page here where we're having to write the names, I want everybody to pick out one problem number, type that problem number in the chat, and I'll work, I think, probably the first 5 that I see. Go. Okay, there's a 9, there's a 20, there's another 9. Okay, and everybody's voting 9. Okay, all right. I think that's good. Waha, there's a lot of numbers. Okay, everybody stop. I think I'm going to go with, I'm saying a few show up several times, so I think I'm going to do number 9 because a lot of people have picked out 9. And I can see why you picked out 9 because it looks big and scary, right? So I've got, let me zoom in a little bit more, SRC2H3022. So remember, when you're writing the name, you need to find the name of the positive piece and the name of the negative piece. The positive piece, or the cation, is always first. And so that's just going to be SR. And I can look up on my periodic table to find out that SR is called strontium. Now, what I want to do is I want to check and see if strontium comes in more than one oxidation, or if it's always just going to have the same charge. So I'm going to look on my ion chart here. I'm looking for SR, and hey, there it is. It's over there in +2. So since there's not a Roman numeral by it, I don't have to put a Roman numeral in the name, and I know that that's the only form that strontium can take. So strontium, now I just need to go find my negative ion, C2H3O2, and find what its name. So I look on the negative side, and hey, it's right there at the top of the list. Okay, the C2H3O2 ion is called acetate. So the name of this is just going to be strontium acetate. And you're like, it's that easy? Yeah, it really is that easy. Let's do number 12, because I see a lot of people in the chat have picked out number 12. I've got YCl033. So again, let's go find, let me straighten that out so that Haley doesn't scream. Okay, so that I need to go find my cation and my anion, my positive piece and my negative piece. My positive piece is just going to be yttrium. So I'm going to make sure I'm spelling that right. No, I'm just going to guess. T-T-R-I-U-M. And then ClO3, I'll find here in just a minute. But first, let me check and see if yttrium is one of those that has more than one oxidation. Okay, I'm only seeing yttrium showing up in +3. So again, I don't have to worry about putting a Roman numeral in there. So it's just going to be yttrium. Now let me go find what ClO3 is. Looking on my negative side, ClO3, oh, there it is. It's chlorate. It says it has a charge of -1. So chlorate. Now again, be careful of spelling because we've got chlorate, we have chlorite, chloride. Okay, all of those are different things, and so I have to be sure I spell it correctly. CHLORATE. And I'm done. How do I spell number 9? Okay. Okay. Strontium is spelled S-T-R-O-N-T-I-U-M, and acetate is spelled A-C-E. I'm sorry, my writing is terrible. A-C-E-T-A-T-E. I know that's hard to read. I apologize. If you've got that chart, this dude right here, which I put up in the stream a couple days ago, then it's spelled correctly on that chart. I apologize for that. Okay, so let me look at some other ones. So I worked number 9, I worked number 12. Let me see which other ones are popping up here quite a bit. There's a 20, a 15, a 14. Let me see which of those I like. I'm not going to do 15 because 15 is easy. I think 14 looks like a good hard one, so we'll do 14 for sure. Let me see, which other one did I see here? 20? Yeah, 20 is a good one to practice on, so we'll definitely do 20. Both 14 and 20 deal with metals that can have more than one oxidation, so I'll show you how to figure that. Let's look at 14 first. 14, zoom in on that. Oh gosh, old man eyes. That is TiCN4. So I'm going to go look up my Ti first. I see that Ti on the periodic table is titanium. Now let me check my chart and see if titanium is one of those that shows up in more than one place, and sure enough it does. I've got a titanium with a charge of 3. I don't see it in the positive 2s. I don't see it in the positive ones. That's actually a TL. That's either thulium or thallium, I forget which. There's titanium with a charge of 4. So we know that we're going to have to, on our titanium, use a Roman numeral to show what its charge is. So I'm going to just put some parentheses there and leave that blank for now, because I don't know what the charge is going to be yet. I need to see what it's bonded to, and it's bonded to this ion that is a carbon and a nitrogen, Cn. So coming back out to my chart, I'm going to look on the negative side for a Cn. Jumps out at me real quick. That is a cyanide ion, and it's got a charge of -1. Okay? So I'm going to do a couple things back on my paper. I'm going to go ahead and write the name cyanide. And I'm going to pull this off to the side here, and I'm going to do Ti, and I'm going to do Cn. Oh, you can't see it there. Okay, now Cn has got a charge of +1. Ti, I still don't know its charge. But I have a total of 4 of these Cn ions. So if I do this times 4, I've got a total charge on the positive side of this of, oh, I'm sorry. Am I writing +1? It's negative, my bad. -1. So I've got a total charge of -4 on this side of the molecule, which means I have to have a total charge of +4 on this side in order for those two to balance out. So since I just have one atom, that atom has to have a charge of +4. And if you look at the formula, if you do the crossing over trick only backwards, then that 4 would go with the titanium, and just one of those would go with the Cn. So to finish my name, I'm going to put a Roman numeral 4, which is IV. If you're not sure about that, then let's look in the positive 4 section. There's titanium right there, and it has an IV, a Roman numeral 4 out beside it. So the way that I would actually say this is I would call this titanium 4 cyanide. Now, really important that you note the 4 doesn't have anything to do with how many titaniums I have. The 4 has to do with this +4 charge that positive piece has. If you see a Roman numeral in a name, that always tells you the charge of the positive ion. Okay? If you have any questions, type them in the chat. I'm going to look at number 20, which is another one where we're going to have to look up the charge. So again, for number 20, I'm going to find my positive piece, which is the first thing I come to. It looks like it's just going to be good old iron. And my negative piece is this HCO3. So my positive piece, when I write iron, I-R-O-N, I look up iron on the periodic table, and I see, uh-oh, it could be charge of +2, or it could have a charge of +3. Okay, to answer your question, you have to include the Roman numeral on this because there are other kinds of titanium. So, for instance, if I had, see there's titanium with a charge of 3 right there. If I had titanium 3 cyanide, then it would have been this right here. It would be TiCN3 instead of TiCN4. See, you've got two different compounds. They have two totally different names. And that number tells you what the charge of that positive piece is. So that would be a +3 titanium. That would be a +4 titanium. Okay, so number 20, I know that iron could be either +3 or +4, so I'm going to go ahead and put parentheses there, knowing that I have to fill them in just a minute when I find its charge. I see that it's bonded to HCO3, so let's go find HCO3 on the negative side. Yell at me if you see it before I do. Oh, I see it. It's right there. It's the bicarbonate ion. Okay, HCO3, it has a charge of -1. So I'm going to go ahead and write for my name bicarbonate. Now, if bicarbonate has a charge of -1, look back in my formula to see how many of those we had. We had 2 of those bicarbonate ions. Okay, that's what the 2 outside the parentheses tells us. So we take this entire thing times 2, it gives us a total negative charge of -2, which means the other side of my molecule here has to have a total charge of +2. I've only got one atom there, so that atom has to carry all of that +2 charge, so this must be iron 2. So I put a Roman numeral 2 in there, not an 11. Okay, this is another really good place if anybody wants to type a question in the chat. I'll see if I can answer it for you. I think what I'd like to do, we're about 17 minutes in, I would like to look at some of the problems on the second page where we are given names and we have to write formulas for them because it's a little bit different. Okay, I'm not going to say easier, I'm not going to say harder, but it is a little bit different. So let's look at the back page. We've got number 21 down through number 40. Let me get it all in the camera here. And just like before, I'm going to take requests on which ones you'd like me to work. So I'll take like the first 5 that people vote for. Go. I'll go for 29, 34. Lots of 29s. There's a 24, 38, 36. Okay. I think we've got enough votes there, so let me see which one's got the most. Okay, so there's lots of votes for 29. And you're looking at 29, and I can understand why you picked that because it looks big and scary. So let's do manganese 7 arsenide. Now, here's the spoiler. If it gives you the Roman numeral, when you're going this way, it actually makes it a lot easier, and I'm going to show you why. Because what I have to do is I have to go find the symbol for manganese, and I have to find the symbol for arsenide. So manganese, the positive one, I find just by looking on the periodic table, and I see that it's got the symbol Mn. Arsenide, I have to look at my negative ion chart here. Now they're listed alphabetically, so it should be in an A. There it is. Arsenide is just an arsenic atom, just as an ion, and it's got a charge of -3. So arsenide is -3. It's just As. and it's got a -3 charge. Now, because manganese tells me in the name that it's got a charge of 7, I don't have to go figure that out. I don't have to look that up. I just have to take this charge, and the charge is +7. Now, we're going to use the crossing over trick to write the formula for this. I'm going to take this 7, I'm going to cross it down here. I'm going to take this 3, and I'm going to cross it down there. I'm going to see if I can reduce that proportion, and I cannot reduce a proportion of 3 to 7. So that's my answer. It's just going to be Mn3 As7. Okay, it's just that easy. Let me see. Some other ones are in the chat here. So 34 got several votes. I think I'll look at 34. Okay. Let's do number 34, which is lead 4 sulfate. So I'm going to find the symbols for both. Lead is Pb, and the 4 tells me that it's going to have a charge of +4. Let's go find sulfate on the negative chart. Okay, sulfate stanate. There's sulfate. Now again, be careful. There's 2 others that are really close with names, but they're a totally different thing. Sulfate is SO4, and it has a charge of -2. So coming back out to my paper here, SO4 with a charge of -2. Okay, so now I'm going to do the crossing over trick. Take the 4 and cross it down there. Put him in parentheses because I know that that has to be intact, and I'm going to have 4 of them. I'm going to take the 2, and I'm going to cross it down here. Now, I want to look at the formula that I've got before I write it in the blank. I've got a ratio of 2 of those. We can see what you're writing. Okay, can you see what I'm writing there? Okay. So I have 2 of these leads next to 4 of these sulfates. I can reduce the ratio of 2 to 4 to a ratio of 1 to 2. And if you can reduce the ratio of your positive pieces to your negative pieces, you have to. So it's just going to be 1 lead and 2 sulfates. So I'll come over here to my blank, and I'm just going to write Pb. I don't have to put the 1 because if there's not a number there, it's an understood 1. And SO4 in parentheses, I'm going to have 2 of those. So it'll be Pb SO4 2. Before I look at another couple, that's a really good place for me to stop and see if anybody has any questions. I'm going to pick out a couple here that are a little bit trickier just because they're not necessarily ones that you would have caught as being tricky. Well, first of all, let me see if anybody else has picked any that are a little bit harder. Okay. Okay, so I've got a vote for, okay, we've done 29, we've done 34. I haven't done 38 or 36. I'm going to skip 36 because I think the 36 is easier. I'll do 38. 29, we've done. So another one that I'm going to do is number 32, because that's not one that y'all would have picked out as being tricky. So I'll go ahead and do 38 because it was requested, but then I'm going to show you why 32 is tricky, and then I'm going to show you how to avoid that trick. So let's look at 38. 38 is molybdenum sulfate. So now, first of all, what this tells me, if there's not a Roman numeral, it tells me that there's only 1 charge that molybdenum can have. So I'm going to look on my ion chart, and I'm going to go find molybdenum. Its symbol is MO. Now, hold on. Oh, you know what? That's a typo on the paper. I am so glad you caught that because it turns out molybdenum can actually have more than one charge. I've got molybdenum as a +2. Do you see molybdenum anywhere else? Oh, there's a molybdenum 6. Huh. Okay. So, since I didn't specify what kind of molybdenum you have to have on this paper, and I need to make myself a note to fix that for next year, you tell me, do you want to do molybdenum with a charge of +2, or do you want to do molybdenum with a charge of +6? And we'll just go with one or the other of those. Okay, I got a vote for 6, vote for 2. So it's even Steven right now. Gonna make me flip a coin here. There's a vote for 6. Okay. So far it's 2. Okay, oh, there's a few more for 2. Now one for 6. It's still tied. There's another 2. Ah, 6, you're tearing me apart. I think it's still tied. 2, 3. How about, I'll just do them both, okay? Because, you know, that way nobody has to fight here. Okay. You can't vote twice, Reed. Okay, so let me get a piece of scratch paper. Okay, so if I did molybdenum 2, let me move this up a little bit. Okay. Then I would have an MO that has a charge of +2. Sulfate, when I go find it on my ion chart, I see that sulfate has got a charge of -2. I think we saw that one a minute ago, and it's got a formula of SO4. So SO4 -2. Love that sound. Okay, if you have to leave to throw up, please leave to throw up. No problem. You have a good day. I mean, aside from the throwing up, that doesn't sound fun. Okay. No, none of the rest of you have that excuse. I'm sorry. I want to see puke if anybody else tries to use that. So if I've got this, then check it out. I've got a +2 here and a +2 here. So I could do my crossing over trick and say that I'm going to have 2 of those, but I could reduce that to just 1 of each, right? So that's what I'm going to do. I'm just going to have 1 molybdenum and 1 sulfate. So if that was the case, my answer is going to be MoSO4. If I just have 1 SO4, I don't have to put it in parentheses. Although if you want to put it in parentheses, that's fine. Just understand that it's not always going to show parentheses if there's just 1 of those. If I was to do molybdenum 6, sulfate, then the MO is going to have a charge of +6. SO4 is going to have a charge of -2. You can do the crossing over trick, or you can just kind of think about this in your head a little bit. If that's +6, how many of these will it take to make -6? And the answer to that, if you're doing 6 divided by 2, I'm going to have 3 of these, right? And just 1 of those. If you don't want to worry about that, doing the crossing over trick means I'm going to have 6 down here. I'm going to have a 2 down here. 2 and 6 will reduce to 1 and 3. So molybdenum 6 sulfate would just be MO, that's not an S, SO4 3. So you pick whichever one of those you want to for 38. Just be sure you write in the Roman numeral right in here so I know which one it is that you did. In fact, I will make myself a note to fix that for next year. I think I knew that last year, and I don't think that I paid any attention to myself. So I want to go back and I'd like to look at 32. We're coming up right on 30 minutes, and I think I'll do 32 and then I will let y'all go. If anybody wants to stick around and ask questions after that, you're welcome to. But 32, we have ammonium oxide. Now, that becomes a problem because if I need to find ammonium, I don't recall seeing ammonium on the periodic table, right? And in fact, if you go look on the periodic table, you're not going to find ammonium anywhere up there. That's because, check this out, ammonium is the only positive polyatomic ion that there is. Remember, a polyatomic ion is a group of atoms that acts like a single ion. Well, ammonium is NH4, and it has a charge of +1. If you remember in the molecule building lab that we did, that's when we took that nitrogen and we had to throw away that extra electron and then put another hydrogen on there, and it gave it a +1 charge. There he is, right there. So ammonium has a symbol NH4 and a charge of +1. So if I come out to the side here for number 32, I'm going to write in ammonium NH4 has a charge of +1. Zoom in a little bit there. Oxide, I go look up oxide. Oxide is an easy one to remember after you're used to seeing these for a while. That's just an oxygen atom, and it has a charge of -2. Okay, I got that off the ion chart, I promise. So when I do my crossing over trick, the 2 comes down here, the 1 comes down here. I can't reduce 2 to 1, and so when I write my formula, it's just going to be NH4 in parentheses 2 O. And that's ammonium oxide. I point that out because I believe that you're going to see, yeah, down here on number 40, ammonium shows up again. So you might want to remind yourself, hey, that's what ammonium is. Looking back at the first page, ammonium shows up right here on number 4. Does it show up anywhere else? I think that's the only place it shows up on the front, but you're going to want to be sure and keep an eye on that. So here's the thing. I am not officially assigning this as homework, but I do reserve the right to change my mind about that. So what I would like you to do, and don't take more than maybe another 15-20 minutes of work on it today, work on some of the ones on both sides that we didn't get a chance to get to, and then we'll talk about them at a later date. And you know, if we show up after Thanksgiving and we're here in person and folks have got this done for the most part, I might just say, yeah, let's go ahead and take a grade on that. But anyway, I'm going to stop the recording. If you have got questions, then you're welcome to stick around. Nobody sign out just yet because I still need to take a screenshot of your names. But thanks for